Good morning, everybody, and welcome to Let's Practice. We are talking about single variable quadratic equations, and this is practice number 4. We're going to continue working, solving these quadratic equations with the quadratic formula. All right, and we're going to use the new tool of the discriminant to see how many solutions should we get. So here is a quadratic equation, and I use a graphic calculator to get this drawing right here. So we expect one solution of x minus 1. Let's see if we get it right. So here I'm identifying a, b, and c. Now let's plug it into the discriminant. Here it is. I put 2 right here. I put 1 right here and a 1 right there. After doing all the algebra, I see that my discriminant is equal to 0, which means that I only have one solution. Now I don't have to go to the quadratic formula. I can just go and try to do a trinomial, because I know I have only one solution. That make guessing the trinomial much easier, right? So after doing the trinomial, I see that I have this kind of shape, which is fitting because I only have one solution. When x is equal to minus 1, all of this is equal to 0, and the equality satisfies. Now, let's do the quadratic formula. And I have this. Great, right? So, of course, I'm going to get the same result. That's a problem if I don't. But the point is that when I'm doing the quadratic formula, I don't have to recalculate this. I'm just going to use this 0 I got from here. I'm going to put it here, and I'm going to get my solutions. So let's do another one. All right. So in here, I have a great example of when I should use the quadratic formula, because there is a lot of large number here, right? 16, 32. Even if I'm going to divide by 2, it's going to be like minus 8 and 16. No, let's do it some other way. Let's do it using the quadratic formula. So let's see how many solution should I expect to have. Take a minute, put it into the discriminant, and tell me how many solutions do you expect to have. Do it now. Great. So let's see what you got. So this is the discriminant. I'm putting the 16 equal minus 16 is b. I have here minus 4 times 2, which is the a, and times c, which is 32. And I'm going to get a discriminant of 0, meaning one solution. Great. Now let's put it into the quadratic formula. And I'm going to have what I have right here. Okay, guys? So it's a very useful tool and make everything shorter and more understandable. And let's do another one. Okay, so what do we have here? Here we have a quadratic formula where there is no b. No, there is a b, but it's equal to 0, right? It's 2 times x to the square, 0 times x, and c, which equal to 2. So let's take a minute, use the discriminant, and tell me what you got. All right, you did it? If not, press pause and do it. So if you did it, let's see what is the discriminant. All right. Oh, I have a negative discriminant. That means no solution. I don't have to continue. I'm not going to have any solutions, right? So you see, it's kind of a useful tool. You'll be surprised how many times you will meet this kind of equations. So we're going to finish practice 4 by giving you some homework. Here I have 2 exercises. This one you need to rearrange to have it to be like a quadratic equation, okay, meaning 0 on one side and everything else on the other side, and add everything which is similar together to get a single x to the square term, one x term, and one with no x term. And here I know it doesn't seem like like a quadratic equations, because I don't have an x to the power of 2. But after you're gonna flatten the fractions and get it into the shape of a quadratic equation, you will see that you do gonna have an x to the square of x to the power of 2. Okay, so solve these two, and I hope gonna have a nice time doing it. If you have a problem with this kind of exercises, especially the first one, I suggest you'll go to the playlist on two first degree equations with two variables. Okay, I'm showing how to solve this kind of exercises. So before we go, the next lesson is going to be a bonus lesson. Okay, if you are interested, what is this creature? How did it come to be? And why does it work? So stay tuned to this bonus lecture. It's a really good one. I love it. It's a very geometrical, elegant solution. It's not mine, of course. Some genius did it a couple of 100 years ago, but it works beautifully. And it's explained why this creature here give us the right answers every time. So see you then at the bonus lesson. Goodbye.